So our goal then, in this case, is to solve for A. There's two parts of this. We've got to be able to set up the equation appropriately and come up with an algebra equation based on the geometry formula. And then we want to be able to quickly and efficiently solve for A. And what this means is this is going to be some calculator work. Whether it's a graphing calculator or not, it's going to be some calculator work. It's much easier to do on a graphing calculator, but you can do it either way. Okay? And I want to talk to you about doing these large extended calculations. Probably as important as any of the geometry you learn this year, and that's pretty important, but as important as any of that is going to be your ability to be able to do big calculations without making silly rounding mistakes. It's something that we never really cover in school. I used to talk about it a lot in my physics class, but we don't want to. It's really a bad idea, and even some of the PowerPoints do it. It's kind of silly, but it's a really bad idea if you're doing a big calculation to get numbers from the middle of that calculation and round them and then use them again. Because when you do that, when I round a decimal, what am I really doing? I'm changing, right? I'm changing it to something that's more convenient to write, but that is different than the actual number, right? Now, in a case like this, it's going to ask us to round our answer to 2 decimal places. But we don't want to do any rounding until we get to that final last step. And then we can round the answer, and that's okay, but I can't round before that. The easiest way to avoid that is to use a calculator, properly. So I only have to hit equals one time rather than a bunch of times. I want you, at first it's going to seem a little awkward to you, but it's something I really want you to learn as much as anything you learn all year. That's a big deal. If you can get that, that's going to serve you very well in all of your math and science classes from this point forward. Okay, so let's take a look at this one then. Now, what kind of animal is this here? What are we dealing with? Surface area of what? Of a, say it again, triangular prism. Right triangular prism, to be exact. Very good. Okay, so what's the formula for calculating the surface area of any prism? Okay, I heard it. 2b plus pH. Now, what does the capital B stand for here? Base. What about the base? Area of the base. Good. So the base area. What does the capital P stand for? Perimeter of the base. Good. So base perimeter. And what does the little h stand for? Height of the prism, right? So in this case, now, describe the shape of the base to me. You already did when you named it, but what the base is a what here? Triangle. It has to be a triangle because of our coffee table analogy. If I'm going to pick this thing off the board and set it on a coffee table, on a flat horizontal coffee table, so that the top of the shape is also horizontal, there's only one way to do that, right? If the bases both have to be parallel and both horizontal when I set it on the table, they would have to be the triangles, wouldn't they? Okay? So what we've got to do then is we've got to be able to plug this information in to this formula in a way that's going to allow us to solve the problem. All right, so let's write the numbers down first of all, how about, on the problem. We're told that y is 20, and it looks like y is going to represent both of those two sides. So that side and that side, correct? Okay, we're told that x is 688, and that's the surface area, right? So capital S is surface area. That's 688. What are some things we have to do to get the base and the perimeter here? If I want to calculate the base of this right triangle, what is the base area? How would I do that? Okay, good. It's good. In other words, another way of saying that would be half of the base times the height. And when I say base this time, I just mean the base of the triangle, right? So half of the base of the triangle times the height of the triangle gives us the area of the triangular capital B base, right? So 1/2 times 20 times 20. Okay, no problem there. That's no big deal. What about the perimeter? Okay, we got a little problem there, don't we? The perimeter is the distance around the base, And that's going to look like 20 plus 20, that part's okay, plus this side, right there. Now describe that. What's significant about that side of the triangle? It's a hypotenuse. It's a right triangle, and that's going to be the long side of the right triangle. So now what's the relationship, the Pythagorean relationship that we can always invoke when we're talking about a right triangle? Okay, good. And that's what I always hear. A squared plus B squared equals C squared, and that's exactly correct as long as C is the hypotenuse, right? So I know then that the length is 20 squared plus 20 squared equals hypotenuse squared, right? Now let's just jump right to the square root, though. If I know that 20 squared plus 20 squared equals the hypotenuse, and let's just call that x somehow, x squared, then isn't x, if I square root both sides, just equal to the square root of all that stuff? Right? So we can write that down right here, how about? Square root of 20 squared plus 20 squared. Okay? And that's the other side of that triangle. Okay? Make sense? Okay. Now, what we want to do here is we want to be able to plug that stuff into our equation, right? So here's the equation that we're working with. If I plug all this stuff in, let's see what we get. If I rewrite the equation, S is going to become 688, right? I get 2 times B, and that's B right there, isn't it? 2 times 1/2 times 20 times 20, right? Okay. And then I get plus the perimeter, which is all this stuff, times the height. What's the height? A. That's what we're trying to solve for, isn't it? Okay, now look what we've got for our equation down here. I've got some big number equals some number that's going to be, right? Plus some number times A. What are the algebra steps I would go through to solve for A? Okay, first I'm going to subtract that number, right, to the other side. Once I've done that, I'm going to do what? Divide by that whole number, right? That whole number right there. Okay? We can do this into our calculator. This is what I wanted to show you. I want you to get used to. Okay, so let's do this whole calculation into our calculator. So first things first here, if I want to solve for A, I know I'm going to have a bunch of stuff, this number minus another number, all divided by something, right? So I'm going to have a big numerator. When I have more than one thing in the numerator, I need a set of parentheses to enclose the whole thing, right? So I'm going to open up a set of parentheses. I've got a 688 already over there. I'm going to subtract this. Now, to say that number, all I have to do is just say 2 times 0.5 for 1/2 times 20 times 20. Okay, and then I'll put the whole thing in parentheses. Okay? So I've got all this stuff in parentheses. Now you told me I wanted to divide that by this big ugly number, right? So I'm going to divide by, in parentheses, I've got 20 plus 20, which I can just make 40. How about 40 plus the square root, so square root of 20 squared plus 20 squared. Okay, now I'm going to hit the right arrow to get out of the parentheses. Or to get out of the square root, I'm sorry. I'm going to close the parentheses, and I'm going to hit enter, right? Because that's the whole thing, isn't it? Didn't I just get A by itself? A is equal to all that stuff on the other side. So if I hit enter, I get the answer by only hitting equals or enter one time, right? So I've got a record here of all of the keystrokes that we just made. Okay, and I'll store that and I'll put that on a document on the website so you can maybe print it out and look at it. But I want you to practice this literally. Get used to putting all this stuff in at once. Now let's test our answer and just make sure we did it correctly. Oops. Okay, so if we want to enter this, let's see, I gotta go down just a little bit. Okay, let's see how we did. So 2 places, what would that be? 4.22. 4.22. Oops, I don't want it there, I want it here. 4.22. Oops, there. Okay, you got it. Make sense? Okay? All right, let me take a screenshot of that. So, tools. I don't want that screen. I don't know. Well, I'll figure that out later. I'll figure it out later. I'll put the same problem up then. Okay, so there's that guy. Let's look at another one. I want to look at this guy right here. All right, so same issue, different problem, but same idea. We're given some information. We want to solve for A, right? What kind of animal is this? Not a cube. Okay, right rectangular prism. Good. Yes, ma'am.
Why did you call him an animal?
I don't know.
Yeah, I think it's an animal. I think you have your animals in your Shakespeare stuff.
I might need to go back and study that stuff a bit. All right, so let's see. Let's plug in the stuff that we know. W is 15, so let's put that there. I know that Y is 6, so let's put that there. And then the surface area is 692. Whoops. Now, does it make any difference here? Let's write down the formula again, maybe too, for a surface area of any prism. You already told me that was 2 times the base area plus the perimeter area times the height of the prism, right? How many different ways could I arrange this? How many different pairs of bases could I choose on this and still be correct? 3. Right there, 3. Good. I could choose the top and the bottom, the way it's currently sitting, or I could tip it over this way and use what's currently the front and the back to be the base pairs, right? Or I could use what's currently the left and the right if I flop it over on its side. Any of those would work, wouldn't they? In any of those cases, I've got 2 congruent shapes that are lined up vertically, right? If I set the thing down on a coffee table, in all of those cases, I'm going to get flat horizontal surfaces, right? Does it make any difference in the answer I'm going to get in the problem? Of course not. Of course it's not going to make any difference, but is it going to make a difference in the ease of the calculation? Yes, it is. It's going to make a big difference, okay? Now, what if I use it the way it's currently set up? Let's just see what's going to happen here. Now, watch this closely. This is another thing I really want you to get used to. this is something that you'll, as you kind of peer into your mathematical futures, you're going to do this a lot more. You probably never have done this a lot in the past, but this gets to be a bigger and bigger deal, finding the easiest way to solve a problem. In calculus, for example, yeah, my calculus students learn a ton of calculus, but probably they spend more time, instead of trying to do the calculus, they spend more time thinking about how could they do the calculus easily. There are oftentimes many different ways to do a calculus problem, but one way is very easy and one way is very hard. And that happens more and more in math. We want to find the easiest approach. Now, what if I take this problem the way it's currently set up? So the top and the bottom are the bases, right? Now, watch what happens. If I want to calculate perimeter, for example, or base area, for example, base area would equal 6 times A. Everybody agree? Okay, what about the base perimeter? The base perimeter would equal 6 plus 6 plus A plus A. So 2 times 6 plus 2 times A. Everybody agree? 12 plus 2A. That's going to be kind of a mess, isn't it? When I plug that stuff into my equation up here, I'm going to get, for surface area, I'm going to get 2 times 6A plus the perimeter, the quantity 12 plus 2A times H, which is 15, right? I mean, that's doable, but you see the problem there? I get those A's showing up all over the place, right? So if I want to solve for A, I'm going to have to go through the hassle of simplifying that whole thing and adding up all the like terms. Everybody see that? Now watch how much easier it is if I don't do it that way. What might be a better choice for the base? 6 and 15. Yeah. What if I use the 2 dimensions that I already know in this rectangular prism to define the base? So I'm going to choose the front and the back to be the base. Now look how much better this is. Then instead of 6 times A, we get 6 times 15, which is what, 90. Okay. Right? The perimeter, instead of getting 12 plus 2A, I get 2 times 6 plus 2 times 15, which is what?
42.
42. Okay? So I can get rid of that stuff. I just get 42. And look how much easier this equation becomes. When I plug in the numbers then, I get 692 for S equals 2 times B. Well, that's 2 times 90 is just 180. Plus my perimeter is 42. Whoops. Look how easy that is. Isn't that much, much easier? I only see one little A up there, and it's easy to solve for that. What are the 2 steps I would go through in order to solve for A? Good. Subtract 180 and then divide by 42. Piece of cake, right? Okay. All right. Good stuff. Let's go work on it.